Assalamualaikum warahmatullahi wabarakatuh and a very good day. I'm Ashraf bin Khalid, my matrix number B0920104226. So, we are from BMMV S1/1 Group B. Today, we will present our solid mechanic assignment that is force and factor of safety analysis from actual structure. Our actual structure is food truck awning, as you can see our title here. So firstly, I will explain our objective of our assignment. Our objective is to draw the details of free body diagram from actual structure that related problem. Our second objective is to develop equilibrium equation from the free body diagram drawn. And lastly is to analyze force members from the structure, that is foot troughing. So as you can see here, our first picture, this is our actual structure that has been captured. That is our foot truck awning. So there is one awning and two support, that is pneumatic piston. So the photo next to our actual structure is the idealized model that has been sketched. That's all from me. Thank you.
Hi, my name is SYAHIR bin SHAPAWI with matric number B0920100069. Now I continue with assumptions. Okay, for this structure, we assume that the material of the awning or the roof of food truck is made from stainless steel. Then for the load, the weight is 5, then multiply with the gravity 6.81, and we got 49.05 Newton for total load. Then for the load acting at one side, the total load is divided by 2, which is we got 24.53 Newton. Okay, for the length of the piston, we estimate approximately 30 cm, which is 0.3 meter. And for the total length of the awning is 120 centimeter, which is 1.2 meter. Okay, for the diameter of the outer steel of the piston is 0.03 meter, which is 3 cm. And for the plastic piston is 0.04 meter, which is 4 centimeter. Okay, for the area, cross-sectional area for the piston, the steel one, with the formula area equal to pi r squared, we got 7.07 multiply with 10 with the power of -4 meter squared. That's all. Thank you.
Assalamualaikum. My name is Annisa Aishah binti ROZIMAN, matric number B0920100143. And I will continue with my part, which is free body diagram for food truck awning. So as you can see, we have 4 free body diagram as shown. So the first free body diagram is the full body of our product, include the roof and the piston. So the force acting on the roof is 24.53 Newton. And as you can see, there are two angles, because our product is positioned like that. So the first angle is 12.7 degree and the second angle is 36 degree. So as for the second free body diagram, which is link AE, we resolve at point A, which is AX and AY. And at point D, because the piston B is connected to the roof D, so we need to find the force at BD. And for the third free body diagram is the link BD, which is the piston. So we resolve at B, so we find BX and BY. And then at the point D, which is the force acting on BD. And lastly, the dimension, which is 30 cm to 120 cm. So that's all for my part. We proceed to the next part.
Assalamualaikum warahmatullahi wabarakatuh and very good day. My name is FARID bin Mohammed and my metric number is 092010027. Now we go for the equation of equilibrium. From the free body diagram, we get the sum of Fs is equal to 0, which is force of AX minus with force of CX plus with 0.809 F force of BD is equal to 0. Next, we need to find the sum of Fy is equal to 0. From the free body diagram, we get the sum of Fy is force of Ay minus with force of Cy plus with 0.588 of force CE is equal to 0. And finally, we need to find the moment of D is equal to 0, which is the negative force of Ay multiplied with 40 minus with force of Ax multiplied with 14 plus force of Cy multiplied with 20, and finally plus with force Cx multiplied with 9 equal to 0. Okay, next we go for the analysis part.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL IZANI AFIFA binti AHMAD and my metric number is B092010073. I will present about analysis of force. First, we resolve load to X and Y component by using triangle law. Theta equal to 12.7 degrees. By using sine theta equal to X over 24.53, we get the value of X, which is 5.393 Newton. And then we use cos theta equal to Y over 24.53, and we get the value Y equal to 23.93 Newton. Then we resolve FBD, force to X and Y component, by using triangle law. Theta is same, which is 12.7 degree, and by using sine theta equal to X over FBD, we get the X is 0.5873 FBD, and cos theta equal to Y over FBD, and we get Y equal to 0.809 FBD. By assuming Fx equal to 0 and Fy equal to 0, we get this equation, and moment about D equal to 0, we get negative 40 AY minus 14 AX plus 527.11 equal to 0. By that equation, we make AX equal to 5.39 minus 0.588 FBD as equation 1, and AY minus 23.93 minus 0.809 FBD as equation 2, and negative 40 AY minus 14 AX plus 527.11 equal to 0 as equation 3. Then we substitute equation 1 and equation 2 into equation 3 to find FBD, and we get the value of FBD is 12.46 Newton, and we make that as equation 4. So we substitute equation 4 into 1 and 2 into equation 1 and 2 to find AX and AY, and we got AX equal to negative 1.94 Newton, which is negative means opposite direction of what it was assumed, and AY is 13.86 Newton. Then we finding Bx and By. Bx equal to 7.33 Newton, and By is 10.08 Newton. And finally, we know compression stress is FBD equal to 12.46 Newton. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish Adli bin Muhammad NAZRUL, and my matrix number is B092010113. And now I will proceed to maximum allowable force and the factor of safety. So to calculate the maximum allowable force, actually we use the tensile strength of the stainless steel, which is 170 megapascal and times by area. So the area we got here is 7.07 exponent negative 4 m squared. So the area here we use formula pi d squared over 4. So the diameter that we get is 3 millimeter. Then we convert to meter. So that's why we get meter squared. So we multiply these two, 170 megapascal multiplied by 7.07 exponent negative 4 m squared. So we get 120 kilonewton. So the maximum allowable force is much less than 120 kilonewton. Then we move to factor of safety. So the factor of safety, we use the formula maximum stress divided by the yield strength. So we get the maximum stress is 120 kilonewton. Then the yield strength is 170 megapascal. So when we divide these two, we get 7.06 exponent negative 4. So the value here is less than 1, so the structure is safe to use. So that's all from me. Thank you.